All right, we're about to work some compound inequality problems. If you missed the notes, you can go watch those and come back because maybe you've already figured this out. But if not, here we go. We're doing the even problems. A number n, so here we go. A number n is less than or equal to -7. Wow, that was tricky. Or, so we're literally going to write the word or greater than 12. So wait, what could be greater than 12? N could be greater than 12. So first of all, this is the sentence converted into an inequality, and then it does want us to graph it. So here is our graph over here. We're going to have -7, we got 0, we got 12. N is less than or equal to -7. That's going to be filled in, shaded to the left, all the numbers less than. And then N is greater than 12, all of the numbers bigger than 12 with an open dot. There's number 2. Number 4, a number R is no less than -1.5. R is no less than. When I think of that, I think R has got to be greater than -1.5. because it's the opposite of less than, right? And if you're like, oh, I don't really remember that. Okay, we'll go up here. And let's see, no less than, greater than, or equal to. Okay, so I suppose I missed an equal to part on that. Because it's not less than, which means it could be equal to. There we go. And, so you could literally write the word and. Fewer than 9.5. So this is, again, R is got to be fewer than 9.5. And if you're like, well, was that a thing that we learned? Maybe. I mean, if you're having trouble with it, that's why I kind of tried to make this thing. And I failed the first time, but I succeeded the second time. So anyway, how would we write this as one big sentence, though? Well, basically, think about it as write the smallest number on the left. The R is going to be in the middle, the biggest number on the right. And you'll notice that this guy got flipped around, right? So it got flipped around when we rewrote it and put it over here because -1.5 was on our right here, and now -1.5 is on our left here. Okay, so now we are going to graph this. Here's our number line, 0, -1.5, and 9.5. We have a closed dot here, an open dot here, and we're going to shade in between. Number 6, solve it, graph it. Okay, number 6, I'm going to divide by -3, divide by -3, divide by -3. If you're one of those people who would prefer to split it up, then by all means, split it up. So I don't prefer to do that. I don't want to write anymore. I am lazy. So here we go. I get -8 is now greater than R, which is now less than or equal to 3. Well, actually, that worked out really nice, right? And if you're like, how did that work out so nice? It's because they actually started in a nice way. They put the biggest number on the left, which we just don't usually do, right? So what happened is we flipped our inequalities, and it just kind of put everything nice and neat in order. And here's the graph. There's 0, there's -8, there's 3. We have an open dot. We have a closed dot, and this is an and. We shade ands in the middle, but you could also double check. R is bigger than -8, that way. R is smaller than 3, that way. And then they're shaded, the overlapping. Number 8. We have an or. So we're just going to treat both of these separately. So here we go. We are going to subtract 3, and I'm going to scooch over here so I can see this. We get -17 is greater than W. I prefer to write it the other way around because I just like my variables on the left. Feels a little bit better, communicates a little bit better, and that's my opinion, that's my habit. I'm going to divide by 3 on this one, divide by 3 on this one, and I get W is greater than or equal to -9. Okay, and then remember, this is an or. How do we know that? Because it says the word or. Let's graph it. We have 0, we have -9, we have -17. We have an open circle, shade to the left, shade smaller than -17. We have a filled in circle, and we are greater than -9. We shade this way. And then just a friendly reminder, this is what an or looks like. In fact, what do you mean that's what an or looks like? An or is kind of on either side usually, and it's because it is an either type of thing, it's a both type of thing, it's a union type of thing. So let's jump back down here and do number 10. Number 10, we have an and. So I'm going to be subtracting 8.6 from all three sides here. And in fact, what three sides? There's this one, and then the middle, and then this side. Okay, so let's see. I'm going to jump to our left to kind of do our computation here. -6.2 minus 8.6, that would be -14.8 is less than or equal to 2n, which is less than, let's see. All right, I gotta break out the arithmetic here. 8.6, we're subtracting, right? So this is 20, that's 14, that's 8. All right, 12.8, there we go. 12.8, and now we're gonna divide by 2. Why are we dividing by 2? Because that 2 is there in the middle. With that n, we want to get rid of it. So on the left, we get -7.4 is less than or equal to n, which is less than or equal to 6.4. Now let's graph it. 0's in the middle, 6.4, -7.4. We have a closed dot and a closed dot, and it is shaded in the middle because this is an and. And also, you just could check that math if you wanted to. Numbers that are bigger than 7.4, -7.4, are that way. Numbers that are less than 6.4 are this way, and that's the overlapping parts. Number 12, oh gosh, number 12 looks like it's going to be so terrible, but it's not. We're going to go ahead and copy-paste him out of here so we can have some space to work. Whoa, that's not what I wanted to happen. Let's zoom out, grab our problem, and go to work. So what I'm going to do is I'm looking at this. I have two different equations, right? So that big red thing is here just to kind of show immediately. I'm going to do something over here, and it's going to have nothing to do with what's over here, okay? So let's go over here. I'm going to divide the whole thing by 7 just because I feel like it. And what's going to happen is these 7s are going to cancel, and I get 5 is less than 2 minus b. If you think, nah, I'd rather distribute, okay, you get 35 is less than 14 minus 7b. You're going to end up in the same boat as me, I promise. So I'm subtracting 2. I get 3 is less than -b. And in this scenario, I'm multiplying by -1. And I get -3 is greater than b. Why is it greater than? Because our sign flips when we multiply by that negative. And as I've said before, I prefer to have my inequality, my variable on the left. So by the way, I'll just show you how you would have ended up the same over here. If I subtract 14, I get 21 is less than -7b. And when you divide by -7, you get -3 is now greater than b. Oh, look, that's what we got there. So there's the first chunk of this. If you're thinking, wow, that took a long time, it was just me doing it twice. So yeah, doing things twice takes twice as long sometimes, right? Right, okay. Just like a second ago where I decided to divide by -7, I'm going to multiply this whole thing by 3. I'm multiplying it by 3. I'm going to multiply this by 3. I'm also going to show you this twice because I feel like you guys want to see me do like, I want to see how you're going to do this, but I also want to see how I would prefer to do it. So here's what's going to happen. This 3 is going to cancel that 1/3. and it will not do anything to this. And if you want to know why, here's kind of why. Imagine if I had 1/3 x, and I multiplied that by 3. Well, this is one term, so when I multiply 3, I just multiply it by this one whole term, and I would just get x. Well, now what if I told you that x is really 15b minus 12? Okay, well, that changes what we know about this, but this is still technically one term. It's just 1/3 times this thing. So when I multiply this whole thing by 3, I would just get 15b minus 12. And guess what? That's what we're going to get right here. 15b minus 12 is greater than or equal to 63. Add 12. Divide by 15, and we get 5. So b is greater than or equal to 5 over here. And again, if we had distributed this 1/3, I promise you would still have got the same thing. So, all right, that seems like we did a ton of work, but here's what we've done. We have an or, so it's this or this. Let's see it graphed. There's 0, there's -3, there's 5. B is less than -3, open dot, less than -3. B is greater than or equal to 5, filled in dot, greater than or equal to 5. We are done. This is what an or looks like. Back to our problems. That was 12. We're not doing 13. We are doing 14. Describe and correct the error that will happen here. Okay. Well, let's see. This guy subtracted 3. He did it there. He didn't do it there. Problem solved. That's it. Well, here, are there any other errors? Let's check out. So then he divides by -2, which he did correctly. He swapped these signs around. Okay, cool. And then he shaded it correctly. Yeah, so the dude just forgot to subtract by 3 right here. Oops. Funny teeth. Okay, great. All right, on these, I'm just writing each of these as an inequality. And it says an inequality that represents temperatures of each element as a liquid. And so the idea is that, so gold, for example, for gold, if the temperature is between, I'll use G, is between these two numbers, then it's a liquid. And if you're like, wait, what? I don't kind of get this. Before this temperature, it's a solid. And then if it starts to melt, then that's when things become liquid. And at this temperature, it becomes gas, because when things start to boil, they become, a gas. I suppose that we could underline them here also, because at this exact temperature, it is not quite boiling. And at this exact temperature, it's not quite melting. For example, if at 1064.01 degrees, boom, we are, well, hang on. By that thinking, then I would want to, okay, you know what? I'm going to go ahead and back up. I would rather say that is the answer, but I know that the answer key says that is the answer. So, you know what? You do you. And just now, we're just going to copy paste the rest of this in this format. So silver is going to be 962, silver 2212, and then copper is going to be 1083 less than or equal to 2567. And then now it says, describe a situation in which someone might need to know the melting point of one of these elements. And my first thought was that if you were going to, actually, I guess I had two first thoughts. My first one was like, you use copper and you want to like coat something like an electronic in it, you would need to melt that copper, and then you apply it to whatever, whether it's a wire or a circuit board, and then boom, it can be used because it will then solidify again. And then the other was like a Bible verse where it's that silver is refined as it's being melted. And there you go. So, because God refines his people as a silver refiner refines silver. 18, solve the inequality, graph it. So 18, we have an or. So I'm going to add, I'm not going to add 1. Oh yeah, I am going to add 1 to get 2m is greater than 6. Divide by 2 to get m is greater than or equal to 3. I'm going to divide by 5 to get m is greater than -5. And I'm just going to copy it over here because why not? And graphing it, we have 0, -5, 3. Filled in dot, m is bigger than that. Open dot, m is, hold on, we have an or and we have 2 graders. Okay, what's going to happen here is that since they both go through each other like this, then that is our answer right here. I guess if you wanted to be simpler, you could do it like this. Here's -5, here's 0. It's open, and then we just shade this way. And if you go look at your answers, you'll notice that it actually only includes, it only includes just that part. Well, why does it include that part? Because this red part just kind of gets eaten up, kind of gets swallowed in there. It's like it doesn't really matter, right? Okay. So a little surprise there. Maybe there'll be some other surprises. We're going to add 8 right here. X is now less than or equal to 12. Or, let's do this one in blue, 2x. We're going to subtract 3 to get 6. We're going to divide by 2, and we get x is greater than 3. Okay, let's see what this one ends up looking like. Here's our graph. We're going to do the green one. Here, hang on. Let's do 0, 3, and 12. The green is x is less than 12, and it's filled in. It goes this way. And the pink is x is greater than 3. It is open, and it goes this way. Okay, so here's something interesting about this. Since it's an or, we can zoom back up here to our notes and go, hang on, it's either, it's both. It's the union of that information. So tell me, we are hitting everything. That is why the answer to this is technically all real numbers, because we are shading the entire thing, okay? And then 22. So by the way, there's kind of 2 special case scenarios. Let's see if there's another one. You never know. Again, this one's kind of large, so instead of me copy pasting, I'm going to do this, kind of cover up this other junk and start answering. So I'm going to add 18, and then notice this and kind of says, hey, listen, we're doing this one separate from this one, so I'm not going to can just continually add 18. And actually, I am not adding 18 to that part. I'm adding 18 to that part. So here we go. This cancels, leaving me with 3.5x is less than 4.5x minus 5. I'm going to subtract 4.5x, and I get negative x, it's just -1, right, is less than -5. Dividing, or here, multiplying or dividing by -1, however you want to look at it, we get x is greater than 5, okay? Let's do the other side. I'm going to kind of slide over here, zoom in just to make it be a little bit more evident what I'm working on. And let's see, that is 38, is that right? And then I got to tell you, I don't know what 38 divided by 9.5 is off the top of my head. So let's see, what if we tried 4? Because this is almost 10, and 10 times 4 would be 400. So let's see, 4 times 5 is 20. 4 times 9 is 36. Oh, look, there it is. It's 4. So x is less than 4. Okay, so we have this guy, and we think it is an and, so let's graph it. There's 0, there's 4, there's 5. X is smaller than 5. Open dot, smaller than 5. And then X is less than 4. So open, it's not. Back up. X, so open dot there, X is greater than 5. There we go. And then the green one is X is less than 4, open dot. Interesting. So like the last one, we said, look, it was both, so it was all real numbers. When it comes to an and, it is the intersection. It is the overlap. We don't have something that satisfies both of them. So this is no solution, because we got nothing. And if you don't believe me, let's slide over, look at our answers real quick. We got no solution. All right, we got 2 more, 24 and 26. 24, the graph shows the annual profits of a company over 8 years. Write an inequality that represents the profits from 13 to 20. Well, let's see. I would think it's going to be profits in the middle. And let's see. It is at least 50. Less than or equal to 50. And at most 90. I think that's it. The profits are between 50 and 90. And last but not least is 26. Complete the inequality. So it's this thing and this thing. And we want to write it so that the solution is only one value. My first thought is to work on this bottom one, kind of simplify it, and who knows, I might be wrong, but we're going to try it out. Previously, you'd seen me like divide by 5 on both sides, but I'm not going to do that here because this 5 would not cancel that 2 and would just make a fraction. And so instead, I'm just going to distribute this 5 and distribute this 2. So we're going to get 5x plus 10 is greater than or equal to 2x plus 16, right? And now let's simplify that. We're going to subtract 10 from both sides. And we subtract 2x. And we divide by 3, we get this. So if you're wondering, wait, why are we doing that? Because if this is an and again, this is just my initial thought, then what's going to happen is we are going to want to have like this overlap. So here is this. X is all the numbers that are bigger than 6, so we're going that direction. And now I'm going to look at this one. So I'm going to zoom out and do it kind of up here. Again, so on this one, I can divide by 2. And what will happen is it kills that 2. And on the left, I would get 2x minus 6. And you might be thinking, well, this isn't all that helpful. I know. But you know what? I did it anyway. I had to deal with those numbers, right? Let's see. I'm going to add 12 and get 2, positive 2. So plus 2, add 12. Let's subtract x. X is now is blank 2. And then let's see. When you go to our graph, we need to throw a 2 on here. So let's see. We only want one solution. So we need to go this direction, I think. So it has to be one value. Well, inequalities are kind of famous for not just being one value. So I think this is like kind of a trick question. So let's actually get rid of, I can't apparently get rid of it for whatever reason. So, okay, we have this red part right here, this red part. And then if we were to make this black part go this way, then what we would have is we would have an and that was like this one. And that was no solution, which is exactly one solution. So let's go with that. Let's go with it needs to be x is less than 2. And so that way we have no solution. So that's my answer is less than. I suppose you could also go with less than or equal to, but it doesn't really matter. There would not be an overlap. So there is all of our questions. Let me know what questions you've got.